As always, you can call me Calamedea, and I'm going to show how to measure crankcase pressure. To measure the crankcase pressure, you will need a multimeter or two, a battery power supply, we'll get back to that, a power supply, well, I'll come back to that too, a breadboard, contact patch, little wires. This is what a breadboard looks like new in the box. 1 bar map sensor or 2 bar map sensor, 10mm or 8mm, something to fit the hose from the engine. Some engines have large or small hoses. This is the hose I'm using for my demonstration. The inner diameter is 8mm on this. This is the approximate length of the tube we're going to use to attach to the engine, but for the demonstration purposes I'm going to use this long one so I can adjust the map. I'll show you in a minute. And pigtail. You'll need a pigtail to plug in the map, and the ends of the pigtail will need to be configured. This is the end for the multimeter, and this is the end for the breadboard. So let's dig in. First of all, multimeter. The first thing you want to do is adjust multimeter to continuity setting, and touch the ends together. I'm going to touch them together. Make sure the multimeter gets near 0. 1 or 0 is fine. If it reads high for any reason, it means something is wrong. Either the battery's low in the multimeter, or the connections are bad, or something with these is bad, something's wrong. I have a second multimeter here. I'm going to do the same thing, turn it on, a little higher quality multimeter. Set to the same test here, continuity test. Grab the ends. Try to do this quickly to save time. Put the ends together. Notice the continuity goes to 0 or close to 0. It's good. So this is good. So I trust this multimeter now. I trust this multimeter now. Always test your multimeter. Keep testing it. The power supply. The power supply here, each battery, each AA is 1.5 volts. So this is 3, 6, 9, approximately 9 volts coming out of this thing. The reason we want 9, I'll explain this from terms of original engine and batteries in the car. The original manufacturer uses batteries that are 12 volt, but they're not always 12 volt. When the system is running, alternator pumps juice into it, making 14 volts, 13 volts, sometimes 15 or 16 volts. And during cranking, the voltage can drop as low as 8, 9 volts. So what we're doing here is we're taking some voltage much higher than 5. This is 8 or 9 or 10 or 15 or whatever, and we're reducing it to 5 with this. And the reason that we do that is the same reason that the original manufacturers do. These map sensors and throttle position sensors generally all run on 5 volts. You can even see right there, 5 volt. And the reason they do that is because as the voltage changes based on cranking or fans turning on and off, and the voltage drain or voltage going up and down, it will not affect the 5 volt. 5 volt will stay at 5 volts. So that's why they do that. You don't have a 5 volt going up and down when the actual battery power goes up and down. This will give us consistent results as we measure. Breadboard. If you've never seen one of these before, do not remove the backing plate. The backing, I know it's like sticky tape, but don't take it off because there's like metal underneath that connects this whole thing together. The way these things work is there's 2 rails. This is the supply rail. This is the other supply rail. I'll use this as a pointer. This is your supply rail. This is your supply rail. They are directional. If you flip this thing around, the negative will be on the bottom. If you flip it like this, the positive is on the bottom. So you have to pay attention to the direction of this, and that matters when you're going to plug in your power supply here. I have a power supply. This thing takes between 7 and 12 volts input. I'll show you in a minute. And it converts it to 3 or 5 volt for your project. In this case, we're using 5 volt. I have the jumper set to 5 volt. Both of these jumpers are set to 5 volt. And if you notice in the bottom, there are two wire stabbers, poles, whatever you want to call them. This is for increased stability, as if you put just one, this thing is probably going to wobble around a lot more, and also increase the current capacity of it. So what we're going to do is we're going to read the top of this thing, and you see there it says, here's my pointer. Where's my pointer? All right, you see on the top here, I don't know if you can, this camera can focus, but there's positive and negative. And we look at the other side, it's the same thing on the top here. The positive is closest to us, positive, and negative's on the top. So you have to match the positive of this close to us with the positive of the rail. If you flip this thing around and you plug this in like this, this thing's going to put power to the negative rail, and you're going to be confused if you don't it's just not good. You might forget that your positive is actually your negative, and vice versa. So you want to match this to this. Then we can go ahead and plug it in. Look at the back. Make sure you get those double pins into it. See how I've got it here? Got it like this. And then you just push it in. Solderless breadboard. There we go. So now I'm going to close this up. You've seen the batteries inside. It's just a bunch of double A's. Nothing special. You can make your own or whatever. As long as this is whatever power source you're using to go into here is 7 volts or higher. 7 to 12 is what it recommends. And this is just going to plug into here like this. And notice there's a little LED, so I'm going to turn this on. Turn that on, and then I'm going to turn this button. It has a little button right here. Push the button. And there it is, it's on. That means that this rail, this whole rail has 5 volts. This whole rail has 5 volts in the positive rail. And so does this rail. This whole rail here is freaking 5 volts. The top is ground, and the top here is also ground. And we'll be using it here in a minute. I'm just going to shut it off for now. We don't need it right this second. So next, let's see, what's next? Next is, yeah, I guess we'll just plug it in and go. Gonna take one of these 1-bar map sensors. These are random 1-bar map sensors. They're different from different vehicles. One is from a truck, one is from a Camaro, I think. Doesn't really matter. Grab any 1-bar map sensor you want. This will work just fine because the way we're gonna do it. I'm gonna take my pigtail here. This is actually for a cam sensor. I used a razor blade to gouge out a pathway on the top here so it could actually plug into these. I'm just going to pick one of these at random. Let's choose this one. And plug this thing in. There we go, it's plugged in. The other end of this. Okay, so you got to pay attention to the which wire is which, right? One on the left is 5. The middle is the sensing wire, the output, and the right side is ground. So that applies to this sensor as well, even though it's not labeled. Some are labeled, some are not labeled. You just follow this. They should all be pretty much the same if they're, you know, related, but you never know. You got to make sure before you plug them in because you could damage it by plugging it in the wrong thing to the wrong thing. So I've got the wires coming out here. I've got them labeled so I don't mess it up. I recommend you label yours. This one corresponds to ground, which of course is the wire on the far right hand side here. I mean, you get it, right? That's the ground. GND, ground. GND is ground. That's this one. Then I have the positive labeled. Positive. Plus 5 volts. It wants 5. So you just apply 5 to this wire, ground to this wire, and the final wire gives us the result, the output voltage. So here's the other ends of these wires. I have the orange wire here as my power. And notice I've used blue on the very end to confuse myself, but I know it's power because I've labeled it. So we're just going to take this and stab it into one of the power. Any one of these power. I can go here, 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 here. It doesn't matter. You pick any one of these plus, or up here. I could take any one of these because it goes to both. So I'm just going to pick an arbitrary one right on the end. I like to keep them kind of far, everything far as I can, far apart. Next we have the negative wire. It's self-explanatory, but I'm being careful to be very explanatory as I go so I don't lose anybody. I don't want to have any problems with interpreting my results here. So these are all negative here, all negative here. Again, I like to keep things far apart, so I'm going to put the minus up here. And there you go. You can see that one's in the negative, this one's in the positive. If I turn this thing on, by pushing that button, the little green LED will go on and the map sensor will be powered up. But we're missing one more thing here. We have to get the sensing wire. So this is the sensing wire. I've put one of these on the end of it because I want to be able to stab it with a multimeter. So let's take our cheap multimeter tool, and I'm going to turn the multimeter on. You're going to put it on the 20 volt measure because we're measuring between 0 and 20 volts. We're going to be measuring up to 5 volts, so that's why you use this 20. If you were going to measure, say, 100 volts or maybe 50 volts, you'd use the 200. This is DCV, stands for DC voltage. There's an AC volts, but I don't recommend playing around with AC unless you want to start a fire. The rest of this, you know, we don't need to worry about it. These are resistance in case you need to measure the resistance of a resistor or whatever. But we're not doing that. We don't need to mess with none of that. 20 is 20, set it on 20, and then we take one of the, doesn't matter which one, red or black, color doesn't matter. Best to use the plus one, the plus side, which is the top one. That way the voltage doesn't appear negative. So I'm going to take that, plug that into my sensing wire here. I'm just going to shove it in there. There you go. So it's plugged in, nice and, you know, it's pretty tight. It's not going to come out on us. That's what I'm, you know, the only thing I'm really afraid of. If you need to, just tape it up, get some electrical tape and wrap some tape around it to hold it on there if you need to. That might be a good idea. So anyway, this thing, map sensor's plugged in. I have this. Now, what about this one? Where does this one go? Where does this one go? So I have these here. These are contact patch. I call them contact patch. They're just wires. They have little pointy ends on one end and female ends on the other. I just take one of these. You just strip them off. See, they tear off. Tear it right off. You get the whole wire off in your hand, and then I cut it and strip it. I'll show you real quick. I might as well. I'm going to take a pair of cutters. I'm just going to arbitrarily cut it anywhere, any old spot. Get my hand on it. There we go. Snip. You cut it, and then you have this nice thing that can be plugged into the breadboard. The end needs to be stripped. The wire stripper. It's one of these things, and strip it with this. I'm not going to do it because I'm afraid to fumble around too much, and you'll wind up with this. You'll have the pointy end on one end and the stripped end on the other. Notice I've got it already used. I've used it to wrap around I'll show you right now. You take this. This goes to ground. It's your voltage return pathway. Plug that into a ground. Doesn't matter, again, I can go up here or I can go down here to one of these grounds. Doesn't make any difference. Anywhere on the ground, pick one. Doesn't matter. And just so you know, just for reference, because in case you've never seen a breadboard before, these are all connected in line here. These 5. 1, 2, 3, 4, 5. Not here. If you want to take from here to here, you need a jumper. So these are connected 5, and all these are connected 5. And these two sets of 5 are separate. So like if I put something here and here, it'll be connected. This one will be connected to all these, and this one over here is connected to all these, and so on. We're not going to deal with that. We're just going to plug this into a negative ground. Then I'm going to take this end and I'm going to wrap it around this. Again, you might want to use some tape. In fact, I think I'm going to use tape because this one will very easily fall off. Never tear it. Always cut it. If you stretch it, that's how you make those tape projects. When you tape something up and the tape starts to unravel itself, it's because you stretched it too much, and especially at the end. So I'm just going to wrap this thing up with some tape real quick. Wrap it really good. There we go. So now it's taped. Shouldn't fall off too easy. Put that into the minus. There we go. So now we should be ready. I'm going to turn the power on. I'm actually going to get it all on camera at once, right? So you can see that the map sensor's plugged in. I'm going to take this hose here. I'm actually going to see the map sensor has a vacuum port. I'm going to take the hose and attach it to the map sensor like this. There we go. It's pushed on. So now we can test it. We're going to test it outside the car. We always test it first, make sure it works. And I got to be extra careful to test it. So here I'm all set up. Let's apply power to the map sensor. And there you go. That's a baseline map sensor voltage. Now, the important thing at this point is, first of all, it should not move much. 4.26, 4.27, and it's steady, pretty steady. It's not going up or down, plus or minus, 0.05. It's pretty much staying still. While it's in this position, we're going to play with the connector to make sure the voltage doesn't change. See, I'm pushing it, I'm pulling on it, I'm messing with it, trying to get the voltage to change, because that will tell me that there is a weak connection somewhere. You have to test all of your connections. I'm going to do the same thing over here. I'm going to take the breadboard and the little power supply and move. See how you can mess it up if you start playing with it. So what you want to do is really secure it well, push, and get that voltage nice and steady. And you do the same thing with this sensing wire. You can even unplug it and then plug it back into a different ground, give it a different hole, and make sure that you get the same number. And then you can do the same thing with the power supply. You can unplug the power from one place and plug it in somewhere else. And what we're trying to do is trip it up to show us a weakness. We want to find all weaknesses in the circuit before we actually test it in a live runtime environment. So it's sort of like debugging. We're looking at this thing and trying to find all the bugs. So I'm going to unplug the ground now. And you see that now we have a maximum voltage. That's as high as it can go. Ground. So I tried different ground, different power, and different sensing wire ground. I'm getting the same number. That's a really good sign. At this point, I would suggest take this multimeter, disable it, turn it off, take another multimeter and test it with another multimeter. Make sure you get the same number. That's all part of setting up, because if you wind up with two different numbers and two different multimeters, guess what? Got a big problem. So anyway, I think we're good. This thing is, pretty steady number. Now we can actually test the map sensor. I'm going to take the end of this hose here. Now this is a pressure sensor, right? There's a little diaphragm inside, and the diaphragm responds to pressure. So all I'm going to do is suck on it like a straw. And you can see that the pressure goes down, the voltage goes down. It's pretty simple. And it goes right back up to where it was. You want that. You want it to go right back where it was. 4.3, 4.29, something like that. In this case. Because that is our baseline voltage. Once you are sure that you have everything all set up and that the voltage is consistent here on the multimeter, it's not jumping around. 0.01 is okay. If it jumps 4.27, 4.28, 4.29, that's fine. You can see how sensitive this thing is. If I just pull a little bit of air out of it, just a little tiny bit, the number changes a lot. So we can be off by 0.03. It's fine. Once you know for sure that you have the baseline voltage, this is your barometric pressure, take a pen and write it down. 4.29. Base. You got to make sure you remember this, because at the end of all your testing and your measurements and everything you do, you're going to do this again. Triple check you get the same number, because if you do a whole bunch of testing and experiments and then you come back in the house and you test your map sensor again and you get a different baseline voltage, now you have no idea what's what. You have no idea when it changed, why it changed, and so forth. So this is very important that you memorize by writing down exactly how much voltage this thing has at barometric pressure. Now, next what I'm going to do is I'm going to blow into the tube instead of suction. So notice that 1-bar map sensors, they're not intended to read boost pressure, but they can actually read around 1 psi of boost. So that's good for us, because it means if the crankcase pressure goes up above barometric pressure, we'll be able to see it on the voltage on the meter. So it can measure both pressure and vacuum. So again, here's a little bit of pressure, and then here's vacuum. And there you go. We've tested it. We've tried to fool it. The baseline hasn't changed. Let's do one more thing so you can understand how this whole thing works. I'm going to unplug this map sensor. Okay, so the map sensor's unplugged. I'm going to take it out of the tube. This is the one we just used. I'm going to set that over here. I'm going to grab the other map sensor. I'm going to plug it into the tube. Plug it into the tube. Plug it in. Now notice, this map sensor has a different baseline voltage. It's not 4.29. It's 4.8. And again, I'm going to try and fool it. Play with the voltage here, make sure this thing is nice and steady. Play with the wires, make sure 4.8, 4.8, 4.8. Yes, 4.8. So depending on the map sensor you use, is going to give you a different baseline barometric pressure voltage. Again, I'm going to apply a little pressure. Very good. And then a little vacuum. So it's very important you measure the baseline pressure that gives you the voltage. Write it down. Try and fool it by playing with your equipment. Play with the wires, play with the battery pack, play with the power supply, play with the, the connection here, play with this connection, wiggle the wires, etc., etc., etc. Try to get it to, freak out on you or fool around that tells you that something's wrong. And if you maintain the steady voltage, doesn't matter what the voltage is. What matters is that it responds to pressure, responds to vacuum, and that it remains absolutely steady when it's just doing nothing. It's just sitting here. And by steady, you know, plus or minus 0.01 or 0.02 is fine. See, it's going 0.8, 0.80, 0.79, that's okay. Little tiny bit. If it jumps to like 4.85, then we have a problem. So there you go. Now we have to test it on the car, and the car will tell us, you know, based on the crankcase pressure, what the crankcase pressure is. It's really that simple. All right, here we are at the car. I'm gonna just turn this on. It's fine, let it run. Most engines, any random engine will have, not most, all engines will have some sort of breather tube. They're generally connected to the air filter. So if you just follow the air filter, eventually you'll find the breather tube. The factory breather for LS1 intakes is actually this, but you cannot use it on boosted application because it'll fill your, it's a giant boost leak. So I have this blocked off. Instead, my breather is here. It breathes from the air filter. And this line here feeds the crankcase, so I'm just going to pull this off. It's not a whole bunch of pressure or anything, so it doesn't need to be clamped on or anything like that. It should just come right off. Oh, there we go. A little bit of force there. So all I'm going to do is take my map sensor, a little map sensor contraption. Notice I've got the short lines on it now. And this short line goes into here. And there it is. So now they're going to reattach this to the crankcase breather hose, which is the valve cover. There's the valve cover port down in there. This just goes on there. Push it on nice. Doesn't have to be perfect, just needs to be on. Has to be on the valve cover breather. So like I said, all cars have a breather. So now this thing's running. I'm going to turn the map sensor on. There we go. So this can be tricky, you know. You got to make sure your connections are all good before you start your reading, your monitoring, and you know, you go back to your baseline voltage, 4.29. There we go. That's what we want to see before we do anything. So, all right. So now I'm going to start the engine. Okay, let's test it. I'm going to apply suction here and test my crankcase. I'm just going to plug the hole with my finger. So that's a good sign when I try to get it on the camera. When I plug the hole, the crankcase goes under a depression. Check these. It's gotta be really sealed up well. Otherwise, you don't really get a suction. Really good suction over here. But notice that you can basically adjust your crankcase pressure at idle by applying a restriction here. If you give it a little restriction, the pressure in the crankcase will drop. I'm not even fully covering the hole. I'm just barely covering it. Let me fully cover it now. Let's see how low. It goes low. If you just leave that hole plugged, it'll just probably keep going down and down and down and down and down until it sucks the oil seals right into the engine. So you don't want to do that. Let's not do that. Let's not pull our oil seals in. Alright, so what I'm going to do now is I'm going to reconnect my PCV system. And I'm going to relocate this inside the car so I can drive the car while I monitor. So I've got my wires to the map sensor running under the hood and into the car. So all you need to do now is, in the car, point the camera at the multimeter, capture the number. You start off with the same baseline as always. That's good. Check all your connections, everything's tight. Good to go. Let's start the car and drive it around. Close the cutout. See that pressure drop? That crankcase pressure drop? Let's do it again. Get going fast enough that I don't have to worry about tire spin. And then just hit it. So I've shut the engine off and notice that it no longer reading 4.29. I've got 4.33 now. And that's probably due to the temperature. If the temperature of the map sensor starts to go up, it might start to report slightly different values, and that's why it's so important to be so sure what your baselines are. So I'm gonna fool around with the wires some, and if it doesn't correct itself, then this will be our new baseline for the high temperature. It might only come down once it cools off. So now what I'm going to do is I'm just going to disconnect my air filter pressure drop and leave this hose open. And we're going to see what difference it makes at wide open throttle to the crankcase pressure. Simple as that. Alright, so remember I've got the hose unplugged, so there's no more pressure drop from the air filter. I'm going to go wide open throttle now. Going down, the voltage goes up. One more time just for the camera. Let's let this thing breathe. Run me off the road when I do that. Alright, here goes. Alright, back under the hood. I noticed the baseline voltage is staying at 4.33. It's very likely that that's due to the temperature. Temperature gets real hot, the voltage can increase. There's a couple more things worth mentioning. Remember, I disconnected this. Before I reconnect it, I'm going to test my crankcase pressure, test to see if the crankcase is sealed. I'm going to blow air into the crankcase like a balloon and see if it can hold the pressure. Here goes. Now I'm holding the pressure. Now, let's see how long it can stay inside. See, that's a good sign, even though it's up only a little. Listen, listen. Did you hear it come out at the end there? Holds it. Now I'm going to pull a vacuum on it and hold the vacuum in it. So I've got my finger holding the vacuum in the crankcase. It's going to pull air through the PCV valve under vacuum, but so slowly that we should still hear something when I don't know if you heard it or not, but I definitely heard it. Word of caution, don't breathe in like I did. It really sucks. Let's do it one more time. I'm going to blow this time. And I'm holding it like a balloon. So it leaks out a little tiny bit, but for the most part holding. So there you go. It's pretty sealed up pretty good. The baseline voltage we're working from now is 4.32. That will likely come back down to 4.29 or 4.30 once this thing cools off a bit. Worth mentioning that if you want the crankcase pressure to drop idle and cruise, you can install a restrictor here. Like I showed you before, you put your finger over it, the crankcase pressure drops. So a little restrictor, like a little plug with a hole in the center, would actually cause a slight depression in the crankcase pressure for idle and cruise. And some manufacturers use that. That's used to be somewhat common, but you see them less and less on modern engines. I don't know why, but it's just something I've seen. You can still buy them for some engines and add them on. And that's it. That's all there is to it. So back inside again. Baseline voltage 4.32. At this point, once you've collected your data, you can convert the voltage to pressure by installing a pressure gauge here and supplying a vacuum here. You can just suck in with your mouth and watch what the gauge does and compare what the gauge does with what the voltage says. and that'll tell you how much pressure you have in the crankcase or don't have in the crankcase, how much vacuum you get. But for me, it's just enough to see that the number actually drops at wide open throttle. And if I want more of a drop, you need a more air filter restriction. You can block the filter with a panel or a plastic bag, or use some creative means to create an obstruction to the filter, and that'll drop this number down as low as you want. No problem. And on the air intake, the restriction that I showed, you can just add a restriction and also drop this number for idle and cruise. Either way, the idea is you can control the pressure. You can control how much vacuum in the crankcase at all times using these methodology.